Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a systems and mechanical engineer and as a theoretical physicist. Today, as with most of my screencasts, I'll be discussing the reciprocal system and how it compares to conventional theory. Just one interesting topic today, the reciprocal system version of the Titus-Bode relation. So here we go. In the reciprocal system, planetary systems result from the supernova explosion of the parent star. The outward moving, in space, relatively slow speed matter eventually reconstitutes as a red giant and then contracts back to the main sequence. So red giant is actually a new star. It's not like an old star as it is in conventional theory. So continuing, the inward moving, which is outward in time, inward in space, intermediate speed matter constitutes the eventual planets. And by the way, if the explosion were powerful enough, you would get a binary star system. If it's weak, you get a solar system like ours. In reciprocal system terms, the low speed and light matter moving outward is termed, quote, substance A, and the intermediate speed and heavy matter is termed substance B. There are three speed ranges in the reciprocal system, 0 to 1c, 1c to 2c, and 2c to 3c. This is because there are actually three dimensions of motion, not one dimension of motion. The intermediate speed range is 1c to 2c. 2c is the dividing line between one-dimensional motion in space, that is less than c, and one-dimensional motion in time, which is more than 3c from our perspective. Between 1c and 2c, the velocity equation flips, which means it's v over t over s instead of s over t. And the motion is in time for the individual particles, but the object as a whole remains in 3D space, and of course it may still have some spatial motion so that the total motion is two-dimensional. The speeds are discretized into units above 1c of 0, 1, 1.5, 2, 3, and 4. This brings the motion to the neutral point within the range of 1c to 2c. Beyond that, the motion is parentheses 4, parentheses 3, parentheses 2, parentheses 1.5, and parentheses 1. There are thus a total of 11 speeds between 1c and 2c, and thus 11 possible planets maximum in which the matter aggregates. The matter aggregates. No, I was right. In which the matter aggregates because the units are at the same relative speed. For the first half, the inner planets, the semi-major axis is proportional to n squared, where n is the speed. Whereas for the second half, the outer planets, the semi-major axis is proportional to 1 over n squared. So now we're going to do some mathematics here. Let A0 equal the semi-major axis of the orbit of the closest planet to the star in units of astronomical units, and let K equal an empirical constant. It's empirical because this value depends on the amount of substance B and the violence of the supernova explosion, and so it has to be determined by iteration or least squares. So, for the inner planets we have AN. Remember, we're using AUs here. So AN equals A0 plus K times n squared in astronomical units. For the outer planets, we have AN equals A0 plus K times 288 divided by n squared in astronomical units, where n equals the speed number given above, and the constant 288 comes from matching equations 1 and 2 at the neutral point between 1c and 2c. Please see reference 1, which is Dewey B. Larson's astrophysical masterpiece, The Universe of Motion, for a more detailed derivation. Now, I've studied 7 stellar systems with the following results. So here we go. I'm going to scroll. For the solar system, A0 equals 0.3871 AU, K equals 0.276. And by the way, Dewey originally said A0 was 0.4 and K was 0.267, but the values given here give a slightly better fit. So that's what I'm using. For Gliese 581, A0 equals 0.0282 astronomical units and K equals 0.0124. For HD 10180, A0 equals 0.02 astronomical units and K equals 0.1100. For HD 40307, A0 equals 0.0468 astronomical units and K equals 0.033. For Kepler 11, A0 equals 0.0910, K equals 0.0013. Kepler 186, A0 equals 0.0378, K equals 0.02. And for Tau Ceti, A0 equals 0.105 and K equals 0.1. Okay, so please note that these values are for the initial positions of the planets after formation and do not take into account the migration of the planets over time due to clearing of the orbits of debris and the gravitational pull of the other planets. Also, perhaps the K values could be further tweaked, but the agreement is still quite stunning. Equations 1 and 2 can even be used to predict the existence of other planets for these systems. For example, for Kepler 11, planet positions 3 and 4 are missing. There should be a planet or debris, at least, at 0.2178 astronomical units and one at 0.3578 astronomical units. So again, the reference here is the Dewey B. Larson's The Universe of Motion. All right, so that wraps it up for today. This is a great achievement of the reciprocal system. The simplest possible treatment of the reciprocal system is my work, The Unmysterious Universe. Basically no equations, all the concepts, all the drawings, so diagrams, you can see how the whole system works. Now, if you do want all the mathematics, please obtain my work, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDF and 711 slides in the PowerPoint file. Thousands and thousands of equations, many, many tables, diagrams. This work will keep you busy for months. Then once you've mastered that, you can go on to my 2 database modules. The Reciprocal System Microcosmos Database and the Reciprocal System Macrocosmos Database. The Microcosmos Database has all the computations for properties of photons, subatoms, atoms, compounds, and alloys. It also includes cosmic or inverse elements. The Reciprocal System Macrocosmos Database has all the properties for astronomical phenomena, like the universe as a whole, galaxy clusters, galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, and voids. Very comprehensive. You get those 2 modules, you'll be able to use the reciprocal system in your scientific or engineering practice. So again, please study the reciprocal system and prove it for yourself. Thanks for your attention.